Now in part B, you're asked to find C such that f average is equal to f of C. You're asked to find that C value. Okay, any ideas? So the idea is f of C, f of C is, using the function notation, f of C is 4 minus c squared, isn't it? So if f of x is 4 minus x squared, f of c is 4 minus c squared, isn't it? Just playing with the, what the function notation means, substitution. And then the idea would be, well, let's set that equal to whatever we got for f average. So that would be 4 minus c squared is equal to 4 minus c squared is equal to 8/3. And so we solve this little equation. Add c squared to both sides and subtract 8/3. Does that make sense? So I'd get c squared is equal to what? 4 minus 8/3. Okay, so 4 is really, what, 12/3? So what do we get for c squared? 4/3. Okay, so what's c equal to? So 2 over root 3. However, well, okay, normally you would put in a plus or minus, right? Why don't we need both of those? Yeah, we're in the interval. In this case, we're in the interval from 0 to 2. So we'll throw out the negative because it's the negative root is not, negative 2 over root 3 is not in the interval. So the only c we're going to take then is c equals 2 over root 3 for part B. Okay, so the idea is if you plug in 2 over root 3 into f, then that height value is the average height of the function over the interval 0 to 2. So then part C says sketch the function f and the rectangle whose area is the same as the integral from a to b f of x dx. Okay, where f is 4 minus x squared and a is 0, b is 2. Okay, so we're going to put it all together. The mean value theorem, the average value idea, all in one nice, neat picture. So let's sketch f. So what's the vertex on that parabola? Okay, so 1, 2, 3, 4. We don't need the whole thing, but we'll start out with the whole thing. What are the x-intercepts? 2 and -2. So, let me do this just to give it a little more space. Let's do this. Okay, so there's your vertex, and then the x-intercepts are at -2 and +2. And so normally you'd graph a parabola that looks something like this. But really, what part are we interested in? Just the part that goes from 0 to 2, right? Okay. Now, what value is, numerically, what value is 2 over root 3? So root 3, I think, is like 1 point something, but just do me a favor. On your calculator, take 2 divided by root 3. Give me the answer accurate to one place past the decimal. What do you get? 1.2? Okay. So that's the best I can do there. So 1 point, I'm going to go over, to 1.2. 1.5 is right about there. 1.2, I don't know, somewhere in there. And then I'm going to just go up to the curve. And this is, I'm just eyeballing it. It's not going to be all that accurate. Go up to the curve. And then draw in the rectangle with base that goes from 0 to 2. And the height is f of c, where c is whatever it was, 2 over root 3, I guess. Okay, so the idea is that this height right here is f of that c value that we just found. Okay, and then this value that I plugged in right there is 2 over root 3. Okay? And that's supposed to be a rectangle, although I got a little off when I drew it freehand, which is fine. Okay? Guess what? That's it for this section.